In this video, we're going to use our knowledge of ratios to write and solve what are called proportions. So before we actually start to write and solve proportions, we probably need to know what it is. So let's write down our definition. A proportion is an equation. So what you should expect to see in a proportion is you should expect to see an equal sign. And this is an equation that states that two ratios are equivalent. So notice we have that word ratio from yesterday. So in general, what this is going to look like, and please notice I'm using letters and not numbers. I'll put numbers in a second. But the general form that you will see is you will see a fraction, I'm just going to use A and B, is equal to another fraction of C and D. So typically A, B, C, and D are some combination of numbers. So you could have something like, 1/2 is equal to 2/4. Notice that those two fractions, remember ratios are really fractions, those two fractions are in fact equivalent. So this is called a proportion because ratio number 1 equals ratio number 2. Now that's just one example of one proportion. This right here is how we say proportions in general. And it's essentially how we ensure that we are representing all proportions in one statement. So now what we're going to do is we're going to look at how it's typically said in words. This is typically said in words as A is to B as C is to D. And so what you can see here is you can actually see the proportions hidden in there. So A is to B, so that's saying A is in your numerator, B is in your denominator, as is your equation, C is to D, so C in your numerator, and D in your denominator. So what we're going to spend the rest of today doing is, now that we understand what a proportion is, we're actually going to work on solving them. And we're going to solve with proportions that you actually have the tools to currently solve. So here you can actually see two ratios. We have 4:5 as x is to 8. And what I notice here is that this actually looks like some equations we've solved in the past. So what I'm seeing here is that I have x divided by 8. And ultimately my goal in this equation is to figure out what x is. So I need to get x all alone. And x is currently being divided by 8. And my way to undo division, so x is by itself, remember a fraction is division, is we are going to multiply both sides by 8. And in doing so, I get x alone on the right and 8 times 4/5 on the left. And while that might seem like a difficult problem to solve, we actually know how to multiply fractions now. We know that we can turn 8/1 into a fraction. So I really have 8/1 times 4/5. And then I simply multiply the numerators and multiply my denominators. So I end up with 32/5. So just by using my knowledge of undoing rules and getting x alone, I'm able to find that x is equal to 32/5, which I would just leave your answer as a fraction. That's perfectly fine. And if you would like to turn it into a decimal, you can use your calculator to divide it, and also list 6.4 as the decimal equivalent of your answer. So either two of those answers would work. So here again we have a proportion, and this one's just written in words. So if we flip back to the beginning of our notes and we take a look, what we'll notice is we have 7 is to 10, that's our first ratio. As is our equal sign in the middle. X is to 100 is our second ratio. So here we have a proportion. We have ratio equals ratio. And remember, the order in which this is written is actually how our ratio is written. So our first ratio is 7 is to 10 as, which is our equal sign here, x is to 100. And here, if you look at this one, it looks very similar to that last proportion, where we want to get x alone and determine what x would have to be in order for this proportion to be a true statement, that 7/10 would equal x/100. So again, we need to undo this division sign underneath the x by multiplying both sides by 100. In doing so, I end up with x alone on the right. I then have 100 over 1 times 7 over 10. So that becomes 700 in my numerator over 10 in my denominator. Remember that we are multiplying across there. And then I know 700 divided by 10 is just 70. So we can see that x is equal to 70. And if we think about that, 7/10 and 70 over 100, we probably could have figured that out in our heads a little bit, but we did the mathematics just to make sure. So here we were able to find that 7/10, that ratio is the same thing as 70 over 100, which in our brains does make sense. Both of them, if we divide both fractions, become 0.7. So while that solving strategy that we've used on the past two slides is great, it doesn't work to help us solve every single proportion we could possibly encounter. So what we're going to look at next is we're going to look at another strategy that we can use that helps us to solve proportions. Now, you're going to realize that this is example 1 again. I'm just going to show you how to solve this same proportion in a different way. So we're going to look at another strategy. So instead of multiplying both sides by 8 this time, we're going to use something called cross multiplication. And before I use this, I need to stress some things, that this cross multiplication strategy only works when you have a fraction equals a fraction. That's it. The only time this works is when you have fraction equals fraction. But here, luckily, what we can see is we have a fraction equals a fraction. So we can use this strategy. So here you'll notice I have fraction number 1 and fraction number 2. So when we use cross multiplication, what we're going to do is we are going to take the numerator of fraction 1 times the denominator of fraction 2. So we have numerator of fraction 1 times the denominator of fraction 2. And that gets set equal to the denominator of fraction 1 times the numerator of fraction 2. So you'll notice fraction 1, we take numerator times the other fraction's denominator, and then that's set equal to fraction 1's denominator times the other numerator. So we're cross multiplying and putting that equal sign in between. So if I write this out over on the side, so I take fraction 1's numerator times the other denominator, that's 4 times 8. That is then set equal to 5 times x. So we're able to write a different equation by using this cross multiplication strategy. So now the left-hand side becomes 32 is equal to 5x. Now we need to get the x completely by itself, so we divide both sides by 5, and we end up with x equals 32 over 5, which if you look back at your notes for example 1, is exactly what we got the first time. So you can see that this strategy also works and helps us to reach that exact same conclusion. So we're going to be using this strategy of cross multiplication for the rest of today. Now, as I said, cross multiplication can only be used when you have a fraction is equal to a fraction. That is the only time that it can be used. It cannot be used when you multiply, add, subtract, or divide fractions. Can't be used in any of those situations. It also can't be used if you have like fraction equals fraction plus 5. It has to just be a fraction is equal to a fraction. So this cross multiplication strategy is a very specific strategy that only works in a very specific case. So it cannot be used in anything other than fraction equals fraction. If you don't see a fraction on one side and a fraction on the other and a single equal sign in the middle, if you don't see that, you cannot use this particular strategy. So now let's use this to solve more complex proportions. So here we can see that x is in our denominator, which already we know is going to make this trickier, but luckily we just learned that cross multiplication strategy. So let's go through it and follow the cross multiplication strategy, because I can see that I have a fraction is equal to a fraction. We can see the two fractions in here. So I'm going to take numerator of fraction 1 times denominator of fraction 2, so 8 times 15. That gets set equal to x times 6. Now I can rewrite this a little bit. 8 times 15 is going to be 120. X times 6 can be written as 6x. We then need to divide both sides by 6, and as we do so, we determine that x is equal to 20, which then, if we kind of realistically think about this a little bit, this is saying 8 over 20 is equal to 6 over 15. Well, if we simplify both of those fractions, this first one's both divisible by 4, so that becomes 2 over 5. This second one, they're both divisible by 3, and that becomes 2 over 5. So we did, in fact, find the correct denominator for that first fraction to make those two ratios, or those two fractions, equivalent. So we have x is equal to 20, because that is what makes this equation true. So now where this seemingly starts to become more difficult is when we start to put more numbers into our fractions. If you're looking here, we still have a fraction is equal to a fraction, but this fraction has x minus 5 in our denominator, which we know is going to make it more difficult. Now, the little trick that I use to make sure that I don't make any sort of errors is if I see something grouped in a numerator or denominator of a fraction, like something being added or subtracted, I go ahead and I add parentheses. And I can guarantee that if you just add your parentheses every single time, you can apply this cross multiplication strategy the same way you did before, and you won't make any errors. So here, if we go through this same strategy, now that we've added our parentheses, we have numerator times other denominator, so 7 times 3 is equal to denominator times other numerator, so I have in parentheses x minus 5 times 8. Well, my left-hand side simply becomes 21. Here, this is really 8 times x minus 5. If you like to look at it that way, that's okay. Really, what's happening here is we need to distribute the 8 to the other two numbers. So we have 21 is equal to 8x. Then I'm going to utilize keep change here and do plus negative 40. So now I just have a two-step equation. My goal is to get this x value here by itself. In order to do that, I need to think about what I need to undo first. And using my knowledge of solving equations from earlier in this class, remember we're undoing order of operations in reverse. So I'm going to add 40 to each side. So this becomes 61 is equal to 8x. Then I need to get x alone by undoing that multiplication. So I'm going to divide both sides by 8, and x ends up equaling 61 over 8, which if you divide that out is about 7.5. It's a little bit more than 7.5. So if you divide that out, that will be your value for x. Yes, that's a very specific value for x, but that is the value for x that if you put it in for x right here, it will make this entire proportion, this entire equation, true. So now these are going to get a little more difficult. Notice we have multiple m values here, but that doesn't matter. We're going to apply the exact same cross multiplication strategy because we have fraction is equal to fraction. So here I'm going to put parentheses around anything that's grouped together. So I'm going to put parentheses there, and I'm going to apply cross multiplication. So I have 6. I know that this is really a plus negative 1m, so I'm going to add that in right away, times negative 5. That's equal to denominator times other numerator, which is 4 times m. So now I'm just going to rewrite this in a little bit easier way to actually read. So I'm going to bring that negative 5 in front and then write the 4m over here as 4m. And then I'm just going to distribute. So I have negative 30 plus, that's negative 5 times negative 1, so that's a positive 5m, is equal to 4m. Now here, while it might have seemed at first like I should add 30 to each side, what I notice is I currently have 2 m's in this problem, and I want to get those 2 m's together. And since this 4m is already kind of by itself over here, I'm actually going to undo this 5m to the other side. So I'm going to subtract 5m, subtract 5m, so I end up with negative 30 is equal to a negative 1m. And then I actually almost have m by itself. I just divide both sides by negative 1, so m becomes 30. Now this might seem a little bit strange, but if we kind of come back up here and brainstorm what this would look like if we were to substitute that 30 in there, that first part, so 6 minus 30, if we put 30 in for m, that would become negative 24 over 4. And if we put 30 in for m here, we would get 30 over negative 5. And if we simplify both of those both actually become negative 6, because 24 divided by 4 is 6, tack the negative on. 30 divided by 5 is 6, tack the negative on. So we can in fact see that yes, this is the correct answer for m because it makes that entire proportion true. So one more like this and then we'll move on to word problems. So again, I can see I have fraction is equal to fraction, so I know that I can utilize my cross multiplication strategy. So I'm going to do numerator times other denominator. So I have y minus 4 times negative 2. That's equal to denominator times other numerator, so 3 times y plus 2. Now remember, I can write this negative 2 in the front. It doesn't matter. I'm also going to utilize keep change there to make sure that I don't make any sort of sign error. Then from here, I'm going to distribute both numbers. So I have negative 2y plus 8, because negative 2 times negative 4 is a positive 8. I then have 3y plus 6. I then need to work on getting all of my y values together. So I can see I have 2 sets of y values here. I'm going to move my 3y over. So I'm going to subtract 3y, subtract 3y. Those then cancel out, and I'm left with negative 5y plus 8 is equal to 6. I'm then going to subtract 8 from both sides to get my non-y values together. So I end up with negative 5y is equal to negative 2. I then need to get y completely by itself, so I divide both sides by a negative 5. So y is equal to, notice, negative over negative is a positive, so positive 2/5. So that's my value for y, where if I were to put it back into this original proportion, would make the equation true. So in these last few slides, we're going to focus on solving word problems. And what we're going to do for each one is we're going to write a proportion. They are all proportional problems, where everything should be proportional over time. So what we're going to do for each one is we're going to write 2 ratios. So we'll have fraction is equal to fraction. And we're going to have the same units in the numerator and then the same units in the denominator for each fraction. And once we write our 2 ratios, we'll have a proportion that is equal, and we'll use our cross multiplication strategy to solve them. So let's get started here. If I read through, I notice that it says 4 notebooks cost $3.20. So I have a feeling that that's going to be my first ratio. So I have 4 notebooks that cost $3.20. So that's my first ratio. Now from here, I need to make a second ratio. So I'm going to put an equal sign in the middle and put a second ratio over here. And that's going to relate to the second part of this problem. And it says how many notebooks. So how many notebooks means a questionable amount of notebooks can you buy for $22.40? So as I make this second ratio, I need to pay very close attention to how I created this first ratio, because I need to make sure I put the notebooks in the numerator and the money in the denominator. So here I don't know how many notebooks I have, so I'm going to represent that by using just a variable of x. So I have x notebooks, and then I have $22.40. So notice that each fraction is notebooks over dollars. Notebooks over dollars. I've kept it the exact same way. So now from here, we're going to use our cross multiplication strategy because we have a proportion. We have fraction equals fraction. So I take 4 times 2240 is equal to 320 times x. So if I take 4 times 2240, I end up with 89.6, which then this is just 320x. I then divide both sides by 320, and I end up with x is equal to 28. Now remember, this is a word problem, so you always want to utilize units. So not only is my answer 28, but I know that I'm finding how many notebooks, so my answer would be 28 notebooks. So let's try our next example here. This one says a jet travels 440 miles in 5 hours. So I can see my first ratio of 440 miles in 5 hours. Then it says how far, so x miles is what I'm seeing, can they travel in 12 hours? So this second fraction needs to be of the same type. It needs to be miles over hours. Well, here I know that I don't know the number of miles. So I'm going to write x miles and then 12 hours. So again, notice the consistency in my ratios. Miles over hours equals miles over hours. So now I'm going to use cross multiplication. So I take 440 times 12 is equal to 5 times x. So now I take 440 times 12, and I find 5,280 is equal to 5x. Divide both sides by 5, and x is equal to 1,056. And remember, I don't stop here. I'm finding how many miles. So this is 1,056 miles. And final example here deals with cooking. So a recipe calls for 2/3 cup butter and yields 18 cookies. So I'm going to make my first ratio here, and this one is 2/3 cups butter and 18 cookies. That's my first ratio. It says how much butter is needed for 42 cookies. So how much butter? So I have x cups of butter, because I don't know how much butter I need, and then 42 cookies. And then I look at my two ratios and I make sure that both are set up the same, which they are. We have cups of butter in the numerator and cookies in the denominator for each. So now I multiply. So I take 2/3 times 42. So 2/3 times 42 is equal to 18 times x. So I'm going to start here by dealing with the 2/3 times 42 because that seems like it might be difficult. But if I multiply and I turn that into a fraction itself to 42 over 1, and then I just multiply across, I end up with 84 over 3. and that's equal to 18x. So that might seem like it's something that's not very nice, but if you take 84 divided by 3 in your calculator, you will actually find that 84 divides very nicely by 3 and becomes simply 28. So we now have 28 is equal to 18 times x. We divide both sides by 18, so I have x is equal to 28 over 18, which isn't super nice, but we can simplify that by dividing each of those by 2. So we have 14 over 9. That's about the best we can do. And then remember that this stands for cups of butter. And so that's our answer. In order to make a recipe with exactly 42 cookies, we would need 14/9 cups of butter.